Hello, if you've not yet completed the do now, you should probably pause or stop this recording, right? The do now, of course, is just the front side of that paper you picked up, and it's a special Thanksgiving edition. We've got 12 people that are going to be coming to a big get together on Thanksgiving, and we got to figure out how to get these people seated together. So if you read through the do now, you can see that you got some square tables. One person can sit on each side. There's an example of if you have just one table, you could seat 4 people. And then there's an example that shows that, hey, if you put 2 tables together, you can seat 6 people. And so the question is, how many ways can you arrange square tables to allow seating for 12 people? Again, make sure you get some answers on your paper before continuing with the recording of the PowerPoint. Now, this is a very open-ended question, and how you interpret the directions will greatly impact your answer. Some of us might say, hey, you know what? There's only 3 ways, right? Following the example, I could say, hey, I got one person at each end, put together 5 tables, I can seat 12 people. Second way, if I have 8 tables, I can put them together in a rectangular array, and again, I can seat 12 people. We can also grab 9 of those square tables and seat 12 people. So some of you will contend, hey, those are the 3 answers. There's 3 ways. Now, depending on how you interpret the directions, however, some of you might say, this one is new, right? And in math, especially when you start getting up into some of the higher level, like group theory, ring theory, right? Assuming you've had a year of calculus in college and you've gotten past differential equations, right? You're a sophomore, junior in college, and you're getting into ring theory, group theory. Big discussion is whether or not you would accept these as unique solutions or if they're duplicates. So some of us would say, hey, no, there's only 3 ways of doing it. Some of us would say, now there's 5, right? There's 5 ways of doing this. Now, this is assuming that the tables must be touching. And the way the directions were laid out, I think most of us would have stopped right there. But some of us would have said, well, gee, what if the tables aren't touching? I have 3 square tables. I can seat 12 people for dinner. Now, they're not going to be at the same table, but I could have 12 people in my home eating Thanksgiving dinner. When I was a kid, this was more the reality because we had such large gatherings at Thanksgiving. There's no way we could all fit around one table. Some of you might say, well, hey, who says they all have to be the same? I could put 4 people at one table, push 3 tables together, there's another 8, that's a total of 12 people. And again, we can have a good discussion on whether or not this next solution is the same or if it's different. And then some of you might go even further and say, hey, the 3 tables put together, I'm going to put on the left-hand side, and the single table I'll put on the right-hand side. And so you might say there's even 2 more ways of showing that. Of course, if we'd like to even things up a bit, we can say, hey, I can have 12 people over for dinner, groups of 6 and 6. I'll just need 4 square tables to do that. Again, some of you will contend that this next one is new and different. Some of you will contend not, it's the same thing. And then, of course, some of you will contend, hey, I can do 6 and 6, but what if they're not aligned the same way? And then some of you might say, well, gee, what if the first one is horizontal, the second one is vertical, etc.? So, again, I think a lot of us would say the answer was 3. Right? I think a lot of us would say, hey, you know what? There's really 3 ways of doing it. Some of us would argue, nah, if we put the tables together, there's like a 4th way and a 5th way. And I think just about all of us would have stopped at that point. But holy cow, depending on how you interpret the directions, right? And so this is why when we talk about order of operations or we talk about portions, this is why we have to have a real clearly defined set of rules, right? Because if we don't have like a clearly set rules for like order of operations, all sorts of really interesting things could happen, right? And so that's why mathematicians, whatever we're looking at, percent, slope, perimeter, area, that's why we have to have really precise definitions. Because if they're not precise, all sorts of interesting things can happen. Now, even though the front side was the do now, some of you probably flipped your paper over and were trying to figure out, what am I going to do with this? Well, you can't do much with this until you get the next paper. Right? So you might have to pause the video and wait till you get the next part. Right? Because you will need the paper that has the grid. Now, the reason why I didn't photocopy these back to back is you need to be able to see the coordinates while you're plotting. Right? So this is why they're on 2 different sheets of paper. You can see the coordinates while you're looking at the grid. And we're going to plot the coordinates on the grid. And then we're going to join the points in order with line segments. So you're going to have 7, well, they call them lines, but they're going to be union of line segments. But it says, you got line 1. That's obviously going to be a lengthy one to do. And line 2, line 3, line 4. Lines 5 and 6 look kind of short. And then line 7. So if you've got all your materials in front of you, I'm going to help you get started. And then I'll go into silent mode and you can work at your own pace. Okay, so it looks like it says my first line needs to start at -20, -5. So I need to line up where x is -20 and y is -5, and I need to put a dot there. Right? That dot lines up with -20 for x, -5 for y. Next one, that -31, comma, -9. So I need to put a dot that lines up with -31 for x, -9 for y. Now, before you go make another point, connect those, right? We got to connect those. And then, oops, my animation's a little bit goofy, and the next point showed up already. Oh, well. So the next point needs to be at -35, -7. So sure enough, I've got a point that lines up with -35 for x, -7 for y. And I need to connect those with a line segment. Next dot needs to go at -34, comma, -4. All right, that's where this one is. Lines up with -34 for x, lines up with -4 for y, and I can connect those. Right, so you're on the Cartesian coordinate system with 4 quadrants, and you just keep plotting the next point, and you just keep connecting from point to point. And when you are done, there will be a picture that you should be able to recognize. Dun, dun, dun. So at this point, I bid you adieu. Have fun, and I will be back on Monday. This is the end. You can stop the PowerPoint now.